Hey guys, it's Mr. Zovath. We're going to be getting started with the second instructional packet. So today we're going to be going through a few examples from the first half of the math section. So let's go ahead and get started. On the first page, we're doing multiplication and word problems. So to get started, you really need to try to pull out the important information, identify what you're going to be working with, what you're going to be solving for, and what operation you will be using as you try to solve the problem. So the first one says, the library has 5 mystery books on a shelf. It has 4 times as many fiction books on another shelf. How many fiction books are on the shelf? So we need to identify the important information that we're working with. You can do that by underlining, you can circle or even highlight areas within the problem that help you know what you're doing. So let's take a look. The library has 5 mystery books. So we know the library has 5 mystery books. It has 4 times as many fiction books. And we need to find out how many fiction books are on the shelf. So when we're setting up this problem, we know that we're going to be using the numbers 5 and 4. They're right there for us to identify in the problem, in the question itself. So we need to find out what operation we're using. How are these numbers going to be interacting with each other to tell us how many fiction books are on the shelf? So it tells us in the problem as well. We know we're doing multiplication. And here's a key word that's going to let us know that's exactly what we're doing in this problem, times. So let's think about it like an equation. 5 times 4. So there's that key word there, 5 times 4, which equals 20. So you can solve this problem by just doing an equation. 5 times 4 equals 20. Or if you need a little extra help or you want to go about it with a different strategy, you can even make an array to solve this problem. So we know that there's 5 mystery books on a shelf. There's our 5 mystery books. So 1, 2, 3, 4, 5. There's 4 times as many fiction books on another shelf. So we need to make 4 rows here total. Two, 3, 4, 5, and then our last row. So we have 4 shelves, each with 5 books, and then you can just count up all of the books that we have in our array. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. There are 20 fiction books on the shelf. So as you work through this page, you're going to be highlighting, underlining, or circling important information, keywords to help you identify what you're going to be solving, and then completing each problem. And the last one, you're going to have your chance to write your own word problem for the equation 5 times 6. On the next page, we're modeling multi-step problems. So we're supposed to write an equation to represent each problem and show our work. Let's take a look at the first question. The Lopez family goes to the movies. They buy 2 adult tickets for $6 each and 3 child tickets for $4 each. Write an equation to represent how much money the family spends on movie tickets, and that will be the variable t. So the process is going to be the same here. We need to identify the important information that we will pull out to create our equation. So we know the Lopez family, they buy 2 adult tickets for $6 each, and then they buy 3 child tickets for $4 each. And we're solving for how much money the family spends on movie tickets and representing that number with the variable t. So how could we set this up as an equation to find t, how much money the family spends on movie tickets? Let's go ahead and lay out all of the ticket prices here. So we know there's 2 $6 tickets. And then we know that there's going to be 3 $4 tickets. So here's all of our tickets. Now, what could we do to find the total number, the total cost that will be represented by T? What operation could we use? Well, we could find the sum of all of these with addition, right? So that could be our equation. 6 plus 6 plus 4 plus 4 plus 4 equals T, or how much money the family spends on movie tickets. So 6 plus 6 is 12. 12 plus 4 is 16. 16 plus 4 is 20. 20 plus 4 is 24. They spent $24. So how else could we solve this problem? Maybe with fewer steps. Well, we could do multiplication. So we know that there's going to be 2 adult tickets times a $6 cost. So that's the first half. Those are the adult tickets. And then we have our 3 child tickets times the $4 cost. And that is going to equal T. So we still need to find the sum of each of these sets of tickets. But that would still get us the same answer of 24. So 2 times 6 is 12, plus 3 times 4, which is 12. So then the problem becomes 12 plus 12, which is 24. So as you're working through this page, look for multiple ways that you can set up an equation for each of these problems. You'll have the opportunity to write your strategies and then explain another variation or another equation for one of these other 3 problems. As we continue working through the packet, we're still going to be working with solving multi-step problems. So on this page, we're writing and solving an equation for each problem. On the last page, the expectation was only to write the equation. Technically, we didn't have to work through and solve it completely, but on this page, we're going to be creating that equation and finding the answer that the question is looking for. So let's go ahead and get started with number 1. Tasha spends 25 minutes reading on Wednesday night. She spends 17 more minutes reading on Thursday than she did on Wednesday. Write and solve an equation to find how many minutes Tasha spent reading on Wednesday and Thursday nights. So let's go ahead and identify the important information in our question here. We know that she spends 25 minutes reading on Wednesday night. We know the exact total that she spent reading on Wednesday. And we know that she spends 17 more minutes reading on Thursday than she did on Wednesday. So we don't know the exact amount of time she spent reading on Thursday, but we know that she spent 17 more minutes reading on Thursday than she did on Wednesday. And then we need to find how many minutes Tasha spent reading on Wednesday and Thursday night. So the total number of minutes she spent reading. We'll represent that with R. So let's find the important information here. Again, we know exactly how much time she spent reading on Wednesday night, 25 minutes. So let's go ahead and bring that down. So we need to find out the exact amount of time she spent reading on Thursday. It doesn't tell us here, but we know that she spent 17 more. She added 17 minutes to her Wednesday night reading time. So 17, she added that to her Wednesday night total. So we can go ahead and bracket those together to represent Thursday night, and then we'll have to add this total once we find it to her Wednesday night read time to find the total amount of time spent reading. So this is going to be our equation. Now, whenever we have an equation set up like this with parentheses, we know that we have to solve whatever is in these parentheses first. So let's go ahead and get started with that. She spends 17 more minutes reading on Thursday. So 17 plus her 25 minutes of reading So 7 plus 5 equals 12. But we're not going to put that 1 here. We're going to bring it up to the top of our tens place. 1 plus 1 equals 2. And then 2 plus 2 equals 4. So now we know she spends 42 minutes reading on Thursday night. Now we can bring that down to our next line. 42. And then we didn't have to do anything here, so we can bring this down. 25. And then we're going to bring our operation symbol down. So 25 plus 42. That is going to tell us how much time Tasha spent reading on Wednesday and Thursday nights. So now we can just add those up. 25 plus 42. 5 plus 2 equals 7. We don't have anything to carry over here. Then 2 plus 4 equals 6. So Tasha spent 67 minutes reading. R equals 67. So for the rest of the problems here on the page, you're going to be creating your equation, setting up your operations, and then finding the answer to the question. And then the last question, you'll have the opportunity to explain how you can estimate to check one of your answers, and then show your work. So for the next couple of pages in the instructional packet, we're stepping away from word problems, and instead we will be multiplying a 3-digit number by a 1-digit number. So you'll be using multiplication to work through each of the equations on this page, and then identifying patterns in one of the problem sets, and also explaining how you can check your answers for one of the last 3 problems. So let's go ahead and work through problem number 4 on the page. We have 499 times 6. So just like with addition and subtraction, we're starting in our lowest place value, so in the ones place, and then working to our greatest place value, the hundreds place. So the first step is to solve 9 times 6. 9 times 6 is equal to 54. Now also with addition and subtraction, we can't put that 5 here in the tens place. We have to carry it up above our tens place here and save that for later. Now we have to do 9 times 6 again, which equals 54, but we have this extra 5 hanging out. So we have to add that to the product of 9 times 6 to find what we place down here. So 54 plus our extra 5 is equal to 59. So 4 plus 5 is 9. 5 plus 0 is 5. So we have 59, and again we're going to carry that extra 5 up above our hundreds place, and then multiply 4 times 6, which we know to be 24. Then again we're going to add our extra 5 before placing it down in our product. So 4 plus 5 is 9. 2 plus 0, because we have nothing in the tens place, is 2. So 29. So 499 times 6 is equal to 2,994. So you'll be using a similar process to work through each of the problems on the page. Again, identifying patterns in problem set number 2, and then choosing a problem between 4, 5, and 6, and explain how you can check the answer that you find for one of these problems. So I just want to provide a little more guidance for this last problem, number 8 on page 15. So you're choosing either 4, 5, or 6 after you've solved it, and then explaining how you can check your answer. So the answer that you have here might be different than a friend who's already worked through this problem. Now, since we've already solved 4, let's go ahead and see what we can do to check the answer. Now, one thing that might help you answer problem 8 is thinking about what multiplication is. We know multiplication to be repeated addition. So 499 times 6 is really asking, what 499 plus 499 plus 499 plus 499 plus 499 plus 499 equals. So repeated addition, except this might take a few more steps than this. So as you are trying to explain how you could check your answer, think about what multiplication is, think about how it can represent repeated addition, and then try to explain how you can check one of the answers out of the three that you can choose from. On the next page, we are multiplying a 4-digit number by a 1-digit number, except the instructions are going to be a little bit different when compared to the last page. Here we need to estimate and circle all the problems that will have products between 18,000 and 32,000, then find the exact products of only the problems that you've circled and show your work. So we had problems like this last week where we had to estimate and then circle the products that fall within a given range. Here they need to be within 18,000 and 32,000. So let's work through number 1. So we estimate a product. We can estimate it by rounding to the nearest thousand. So we have 8,491. We want to round to the nearest thousand. So we have 8 in the thousands place. Now we have to look to the next place value to determine how we're going to be rounding. We have a 4 in the hundreds place. So if a number is 5 or more, we're going to raise the score. We would raise the number and the place value we're looking to round. If it's 4 or less, we let it rest. We don't do anything with it. And seeing here, we have a 4 in the hundreds place, so we're going to let this 8 rest. So 8,491 rounded to the nearest thousands is 8,000. So then our question becomes, our problem becomes 8,000 times 2. So we know anything times 0 is going to be 0. So we can go ahead and do 0 times 2. It's going to be 0 through the ones, tens, and hundreds place. And then we have 8 times 2 in the thousands place, which is equal to 16 thousands. So we have an estimated product of 16,000 that does not fall on our range here of 18,000 to 32,000. So we can go ahead and remove this circle, and we do not have to find the exact product. Now let's go ahead and do one more. Let's go ahead and work through 2. We'll start by rounding 6,148 to the nearest thousand. So 6,148 rounded to the nearest thousand. We have a 6 in the thousands place, a 1 in the hundreds place. So 4 or less, we're going to let this 6 rest. So we have a rounded 6,000 times 4 to find our estimated product. Again, the ones, tens, and hundreds have zeros. So anything times 0 is going to be 0. So 0 times 4 is 0, 0 times 4 is 0, 0 times 4 is 0. Now in the thousands place, we have 6 times 4, which is equal to 24 thousands. And that falls within the range here. That falls between 18,000 and 32,000. So we're going to keep this circled and solve for the exact product. 6,148 times 4. All right, now that we have it set up, we're going to go ahead and start solving from the ones place to the thousands place, working from the least place value to the greatest. So 8 times 4 is equal to 32. Now again, we can't put that 3 here in the tens place. We're going to carry it up to our tens place. We have 4 times 4 is equal to 16 plus this extra 3. So 6 plus 3 is 9. 1 plus 0 is 1 to give us a 19. we're going to carry that extra 1 up top. 1 times 4 is 4, plus our extra 1 is equal to 5. And we're not carrying anything up top this time. And then we have 6 times 4, which is equal to 24. So we have an exact product of 24,592. So for each problem on this page, you will be going and estimating the product, and if it falls between 18,000 and 32,000, you'll find the exact product, like how we did it here. And then after you finish 1 through 12, you have the opportunity to explain what strategies you use to solve the problems. So pages 17 and 18 have us multiplying by 2-digit numbers, so we'll be estimating each multiplication problem to check if the student's answer is reasonable. If not, cross out the answer and write the correct answer. So we have an example for multiplication problem number 1. It's 14 times 7. The student answer that was provided is 2,380. We estimated the product of 280. So this doesn't seem like a reasonable answer. We're going to cross this out, and then 238 was found to be the exact product of 14 times 17. So let's work through that to see how that was found. We have 14 times 17. So we're going to be working from the smallest place value to the greatest, multiplying each number in the top number here in our 14 by each individual place value in our bottom number. So it would be 14 times 7, we'll write the product here, and then 14 times 1, we'll write the product here. So 4 times 7 is equal to 28. So we can't put that 2 here, we have to carry it up to the top of our tens place. So then we have 1 times 7, which is equal to 7, plus this extra 2, which equals 98. So now we can multiply each number at the top by our tens place. So technically we're doing 14 times 10. Since we're not working in the ones place at all anymore, we're going to add a filler 0 here in the bottom. So now we have 4 times 1, which is equal to 4, and 1 times 1, which is equal to 1. So now we have the product of each place value in the bottom here, and we need to add them together to find our final product of 238. So we have 8 plus 0, which is equal to 8, 9 plus 4, which is equal to 13. We'll carry that extra 1 up to the top of our hundreds place, and then we have 1 plus 1, which is equal to 2, 238. So this answer checks out. Let's go ahead and work through one more. We have 15 times 9. The student answer is 285. So let's go ahead and estimate the answer for this multiplication problem. We'll do the same thing here. So for 14 times 17, they rounded 17 up to the nearest 10. So the 7 is 5 or more. They raised the score. Let's do the same thing here. We have a 9. So that's 5 or more also. We're going to raise the score. So this becomes 15 times 20. Now let's go ahead and work through that the same way we did this, just so you guys can see another example. We have 5 times 0, which is equal to 0, 1 times 0, which is equal to 0. Now we're working in the tens place. We're going to add that filler 0 on the bottom here. We have 5 times 2, which is equal to 10. We're going to bring our extra 1 up top. 1 times 2, which is equal to 2, plus this extra 1, which is equal to 3. So now let's add each product from our bottom number here to find our final estimated product. So we have 0 plus 0 is equal to 0, 0 plus 0 equal to 0, and then we have technically 0 plus 3 is equal to 300. It looks like the student answer is pretty reasonable. So this checks out. We won't have to cross it out or find the exact answer. In this case, we're good to go to move on to the next problem. Once you've finished working through each problem, estimating products, finding exact products if the student answers don't seem to be reasonable, you'll just have to explain how estimating a multiplication problem helps you know if your answer is reasonable. So right here, you have the opportunity to explain how estimating might help you to check a provided answer. And the answers for this will vary depending on how you're estimating and exactly how you're checking these answers. So don't be worried if you're checking answers with a friend or you're working with the parent. You guys are explaining it differently, because this is another example of a word problem or a chance to explain where, again, your answers might be different from a friend's or a parent's. All right, so that's going to be it for this week's video. Have fun working through the rest of the instructional packet. If you need any help, do not hesitate to reach out to us. We are available on Teams throughout the week and happy to provide any additional examples, any help that you might need to finish up the problems in the packet. We'll look forward to seeing your answers. Have a good week, guys.